Hi, welcome again. In this lesson, we will see how to work with the if-else statement. We have seen how to use the if statement in our previous lesson. So here we will see the extended version of if statement with the else part. We can use if statement only if we want to do some specific tasks with the Boolean expression and omit the rest of the action if the Boolean expression in the if statement becomes false. But what if we want to do some other tasks if the Boolean expression in the if block becomes false? So in such situations we can use the else block of the if statement provided by the Python control flow execution statements. The else part is optional, but it is very useful to do a specific action if the Boolean expression in the if block becomes false. So if you consider this as an anonymous function, if you consider this as an anonymous program, so this is how the if else statement looks. So here you can see the general form of the if else statement. So if and then the condition, then colon and the if block. If the condition becomes true, then if block will be executed. Else is an optional part, but it is very useful. So if the condition in the if block becomes false, then it will move to the else part. So else block will be executed so that we won't lose any meaningful information. Okay. So here is the flowchart. So first if test expression. So test expression is nothing but the condition if statement and then the condition test expression. If the condition becomes true, then the body of the if block will be executed. If the condition becomes false, the body of the else part will be executed. So if this condition becomes false, then the body of the else part will be executed. So after that, after the entire if else block, we may find some other codes in our program. And before we encounter this if else block, we may find some lines of codes in the program, and after this if else part we may find some other codes in our program. Just this if and else part can make a simple program, but usually longer programs will not have a simple if else part. There may be n number of functions, built-in functions, user defined functions, classes, etc., etc. So in that case it will act as a simple control flow statement inside a big program. So here also the explanation of the if block remains same, only we left with the else part. Okay. And one more thing to remember is the else part indentation should also match the if block indentation. So if the else part indentation do not match with the indentation of the if block for which this else block belongs to, then we will get an error. Okay, like here what I am showing here, the indentation from the if block should match with the indentation in the else part. Okay, so here we can see the indentation of the else part should match with the indentation of the if block or if part, otherwise we will get an error. Let us move on to the practical work to see how the if else statement works. So here I am going to compare the two numbers for the sake of understanding purpose. Okay, comparing two numbers. For example, x is equal to int. Let us take two values. Enter the number and then y is equal to, enter the number, then if x is equal to y, then print x is same as y. Now the cursor is pointing inside the if block. If I press enter, then also it is pointing inside the if block. So what I need to do is to come back, press backspace. Okay, let us put an else part, else, and in front of the else part we should not put any condition, because the else part will execute only if the condition in the if part becomes false. So no need to put condition here, otherwise we will get an error. Print x is not the same as y. Okay, next it is waiting for the another line to enter, so I will just come back to the initial position of the line editor. Okay, by pressing back. So let us save this. And press F5 to execute. Let us enter the number 8 and one more number, for example 7. So look at here, x is 7 and y is, sorry, x is 8 and y is 7. So 8 is not equal to 7, hence this condition becomes false. So the if block will not be executed, so we left with the else part. So x is not same as y. So this is how the simple if else statement works. Sometimes we need to check more than one Boolean expression in our test condition to execute some actions. So in that case we can use the compound Boolean expressions. So here we can see the compound Boolean expression. Here E1 and E2 are the two Boolean expressions, and is the logical AND operator, and OR is the logical OR operator, and NOT is the logical NOT operator. So we have seen that the logical AND operator to be true, both the conditions must be true. Okay, otherwise the result becomes false. And for the logical OR operator, any one of the condition, either Boolean expression 1 or Boolean expression 2, should be true in order to become the result as true. Okay, if any one of the expression is true, the result will be true. And in case of not, here we are considering only the even expression. If the expression even is false, look at here, then the result becomes true. So false, true, true, then false, true, then false. So this is how the compound Boolean expressions operate to check for the specific condition. So from this we can conclude that a combination of two or more Boolean expressions using the logical operators is called a compound Boolean expression. The important note here is the OR operator is an inclusive operator, not as an exclusive, because if either of the expression E1 or E2 is true, the condition becomes true. Whereas the AND operation is an exclusive, because AND operation becomes true only if both the expressions are true. And the logical NOT operator, as said earlier, will reverse the truth value of the expression to which it is applied. If the expression even is false, then it results true. If it is true, then it results false. Let us see how the logical NOT operator works. For example, here in the interpreter, I would like to say that x is equal to 10 and y is equal to 11. Note here that if I do the equality operator, x is equal to y, definitely x is not equal to y, so we got false. What if we use NOT operator, and inside the NOT operator x is equal to y? So look at here, x is equal to y. Is x equal to y, the condition is false. So the same condition will be applied here. Instead of writing the false, I am just writing an expression, so it results true. So it is not is x equal to y is equivalent to writing the expression like this: x is not equal to y. So this results true. So not is x equal to y is equal to x is not equal to y. And similarly, not x is not equal to y, not x is not equal to y is just a more complicated way of expressing x is equal to y. is x equal to y. So we should be very careful while analyzing this type of compound expressions or Boolean expressions with the not operator. So if I try to explain more, if x is less than y, it is equivalent to writing x is greater than y, or if x is greater than y is equivalent to write as not x is less than y. So from this we can easily conclude that not of not an expression becomes true always. So not of not e means not operation of the not expression is equivalent to just an e, okay, just an expression. So this is known as the double negative property of the mathematical logic. For example, not of x is equal to y. So we know that x is equal to y. Is x is equal to y, the condition is false. So not of false is nothing but true. So not of true is nothing but false. So let us see the Python operators and their precedence in Boolean expressions. The binary multiplication operator has the highest priority, and unary plus and minus operators have the second highest priority, and the associativity is from right. Okay, binary multiplication is from right, and unary positive and negative operators have the right priority, and binary multiplication, division, floor division and modulus operators have the left associativity, and binary addition and subtraction. So unary operators are read as positive and negative, whereas the binary plus and minus are read as addition and subtraction operators. They have left associativity, and binary greater than, lesser than, greater than or equal to, lesser than or equal to, is equal to, is not equal to have the left associativity, and unary not, binary and, binary or have the left associativity. The not operator has the right associativity, as we have seen just now in our program in a small code, right? So here you can see the first expression is at right side. Okay, so not is on left side, the expression is on the right side, and not operation is on left side. So not is having the right associativity. Apart from these operators, the parenthesis has the highest priority. Okay, you should not forget that one. And here we should keep in mind that AND operator has the higher priority than OR operator, and NOT operator has the higher priority than and OR operators. So this is very important. NOT operator has the highest priority than and OR, whereas AND operator is having the higher priority than OR operator. The and OR operators have lower precedence than any other binary operator except assignment. For example, x is less than or equal to y and x is less than or equal to z is equivalent to x is less than or equal to y, means writing inside the parenthesis, and x is less than or equal to z. This means if y is greater than x and it is less than z, then we can simply express as x is less than or equal to y. Actually it is nothing but y is greater than or equal to y and it is less than or equal to z. So y is greater than x but it is less than z. In Python we can use more than two variables to test the equivalence of their values. Okay, for example, if x is equal to y is equal to z, is x equal to y and is y equal to z. In Python we can also assign the test condition to some other variable as the expression for the later code usage. So for example, here we have a code assigned with the value 10 and y assigned with the value 20. Here we are checking x is it equal to 10. If x is equal to 10, the condition becomes true. Obviously x is 10, so 10 equal to 10 becomes true. So this true expression will be assigned to the variable b1. Okay, and if you look at the variable b2, we are checking x not equal to 10, but actually x is 10, so this condition becomes false. So this false expression will be assigned to the variable b2. So here we have the compound expression with the AND operator. AND is the logical operator and the complete expression is called as an compound Boolean expression because it consists of expression E1 and expression E2 with the AND operator. So here x is 10, 10 equals to 10 becomes true, and y is it equal to 20? Yes, y is 20 here, so 20 equals to 20. So both this expression E1 is true and this expression E2 is also true. So true and true becomes true, and that will be assigned to the variable B3. So in the fourth variable B4, x is not equal to y, condition becomes false, and y equals to 20, condition becomes true. So false and true becomes false. So and it is assigned to the variable B4. And variable B5, x is equal to 10, condition is true, this condition becomes false, y is not equal to 20. So true and false becomes false, and this is false statement or false expression is assigned to the variable B5. And in the variable B6 we are using x is not equal to 10, and we are checking once again y is not equal to 20, but actually x is 10 and y is 20. So both the conditions are false, hence the result is false because of the AND operator. So this false expression will be assigned to B6. And here if you look at the OR operator, x, this condition becomes true and this condition becomes true. When both are true, the result is also true, and that will be assigned to the variable B7. So here this condition becomes false and y is equal to 20, this condition becomes true. False or true becomes true in logical OR operator, so the true will be assigned to the variable B8. Similarly, other two variables B9 and B10, the true will be assigned to B9, and here false will be assigned to the variable B10. Let us save this and run the program. So here is the result. If I just call any one of the condition, for example, if B1, because B1 is nothing but true condition, okay, if true, instead of writing the expression if x is equal to 10 or is x equal to 10, just I am writing B1, okay, then print it is B1. Here just I am printing B1, okay, it is B1 true. So look at here, the if block has been executed and there is no error because we have saved true condition for the variable B1. So we know that in Python any Python expression can serve as a conditional statement in if block or if statement, okay. let us try to print the statement. It is b2 for variable b2. Okay, it is b2. So look at here, since the expression b2 is false, hence the code inside this if block has not executed. Okay, let us try with the b3. Since b3 is true, the variable has true value, so let us print it is b3 true. Yes, we got it is b3 true. So this is how we can save the variables with the different conditional expressions. Here the conditional expressions are true and false, so we can assign true or false by making several conditional codes with the help of compound Boolean expressions, and we can use later anywhere inside the same program. Here the important thing we need to remember, or we need to observe, is in the expression e1 and e2, here both the sub expressions e1 and e2 are false, hence the result is false. But the result becomes true only if the sub expressions e1 and e2 both are true. Since the AND operator evaluates from left to right, so here you can see the associativity from left to right. This means if the expression e1 which is at the left side is false, there is no need to evaluate the expression e2. This means if e1 is false, no value of e2 can make the expression e1 and e2 as true. It means the AND operator first tests the expression to its left, that is here e1. If it finds the expression to be false, it does not bother to check the right expression, that is expression e2. This approach is called short circuit evaluation in Python. In the similar fashion, in the expression e1 or e2, if e1 is true, then e2's value is irrelevant, because if the expression e1 is true, it does not bother to check the expression e2. It means if expression E1 is true, then without checking the expression E2, the OR operator will result true. Okay, so look at here, false, expression E1 is false, whereas expression E2 is true. If the expression E1 is false, then only it will check for the expression E2. If the expression E1 is true, then the logical OR operator will not check the expression E2, which is false, because the expression E1 is true. So look at the associativity, it is left, from left to right. So if the expression E1 is true, directly it results true. Similarly, if the expression is false, then only it will check for the expression at the right side. So both and or logical operators use short circuit evaluation. So why is short circuit evaluation is important? So why it is important? Two situations show why it is important to consider. The first one is the order of the sub expressions can affect the performance, and the second situation is sub expressions may be ordered to prevent runtime errors. So these are the two situations why is short circuit evaluation important. The order of the sub expressions can affect performance, means when a program is running, complex expressions require more time for the computer to evaluate than simpler expressions. We classify an expression that takes a relatively long time to evaluate as an expensive expression. If a compound Boolean expression is made up of an expensive Boolean expression and an less expensive Boolean expression, sub-expression, and the order of evaluation of the two expressions does not affect the behavior of the program, then place the more expensive Boolean expression second. In the context of the AND operator, if its left operand is false, the more expensive right operand need not be evaluated. In the context of the OR operator, if the left operator or the left operand is true, the more expensive right operand may be ignored. Okay, so in AND operator, the more expensive right operand will not be evaluated if the left operand is false, whereas in case of the OR operator, the more expensive left operand is considered and the more expensive right operand will be ignored. So in order to illustrate this, let us consider a small snippet of the larger program. For example, if x is less than 10 and input print value y or n, So here it looks like an expensive code snippet. X is less than 10 is very simple expression, whereas input enter the value of y and check whether this value y is equal to y, or we are taking the input from the user, and if the user enters y, then this expression becomes true. If the user enters no, then this expression becomes false, because n is not equal to y, but we are comparing with the equality check operator. So this type of expression, or the operand, is nothing but the expensive operand. So that is nothing but the left operand is nothing but a simple operand, and the right operand is nothing but an expensive operand for the compound Boolean and expression. Suppose if x is not less than 10, it means if x is greater than or equal to 10, then the user's input is not considered in compound and Boolean expression. This is the explanation for the short circuit evaluation. So though the expression x is less than 10 is true, only if the expression x is less than 10 becomes true, then the expression in the right side will be evaluated, or the user input will be evaluated only if the left operand is true. Otherwise the user input will be neglected, or it will not be evaluated in case of and compound Boolean expression. Suppose if we reverse this order, for example, if first I will enter the value taken from the user, and then I will use the compound and expression to check the two condition of the two expressions. One is check whether the user has entered y or n. If the user entered y, then this condition or the expression becomes true, means the condition of this expression becomes true. Once the condition becomes true, here the highest priority is given for the user input. So if the user enters y, this condition becomes false, true, then x is less than 10 will be neglected, or it will not be evaluated. If the user enters n instead of y, then this left operand expression becomes false. When this expression becomes false, in the AND operation, x is less than 10 has no importance, because once the condition becomes false, the AND operation always results false, because uh, the AND operation becomes true only if both the expressions are true. So here the user input is very important. Even though the expression in the right side is true, and if the expression in the left side becomes false due to an user input, then expression in the right side has no importance, means it gets less importance. So this is the meaning of the short circuit evaluation. So this is the meaning for the first importance, that is the order of the sub expressions can affect the performance. The second importance is sub expressions may be ordered to prevent runtime errors. This is especially true when one of the sub expressions depends on the other in some way. For example, if you consider the expression like this, x is not equal to 0 and z is divided by x and the result is greater than 1, means the division of z by x is greater than 1. Here if x is 0, suppose if x is 0, then the division by 0 is avoided, so we cannot divide by 0. So in this case it results an error. It means if the sub expressions were switched, a runtime error would arise if x is 0 in this case. Now let us see the importance of the pause statement in ifelse conditional expression. Some beginning programmers attempt to use an if-else statement when a simple if statement is more appropriate. For example, in this simple program, the user wants to do nothing when x is less than 0. Otherwise, the programmer wishes to print the x value. So look at here. Here we are getting the value from the user using this statement, and if x is less than 0, we need to do nothing. Okay, if x is less than 0, if this condition becomes false, then we need to print the value of x. But this is not the legal Python code, because the if block should not be empty as per the Python if statement. as we have seen in the previous lesson. Okay, here the else block contains the print statement but not the if block. Here we have written one comment, do nothing. This will not work inside the parentheses, but comments do nothing in program. So comment does not count as a Python statement. Both if as well as the if and else statements require an if block that contains at least one statement. Here there is no statement, it is a comment. Additionally, an if-else statement requires an else block that contains at least one statement. So here the else part contains one print statement, but there is no statement inside the if block. So if we try to run this code, we may get an error. Let us try. Yes, expected an indented block after if. So there is no statement. So how to run the program in such situation? Okay, so fortunately Python has a special statement called as pause statement. That means do nothing. We may use pause statement in our code in places where the language requires a statement to appear, but we wish the program to take no action whatsoever. So we can use pause here instead of the comment, just the comment to do nothing. Okay, so that's what we have done here. Using the pause statement. So we have also written the comment in front of the pause statement. If x is less than 0, do nothing with the help of pause statement. If the expression becomes false, then print the value of x. Let us run this now. Let us enter the negative value because x is less than y. If this condition becomes true, if the condition has to become true, we need to enter the negative value. So for example, -3. See, the pause statement is considered as the valid Python statement and if block has been executed. So there is no display of the print statement inside the else block. Let us run this code once again, and this time I would like to enter +3. Okay, +3. So now this condition becomes false. So when this condition becomes false, no block of the if statement will be executed, including pass. Means pass is just an statement which do nothing. Okay, hence else part will be executed. So else part is printing the value of x entered. Okay, here in our case 3. While the pass statement makes the code legal, we can express its logic better by using a simple if statement. In mathematics, if the expression x is less than y is false, it must be the case that x should be greater than or equal to y. Okay, if x is less than y, it means that it should be equal to x is greater than or equal to y. If we invert the truth value of the relation within the condition, we can express the above code more succinctly as like this: if x is greater than or equal to 0, print x. So instead of writing if x is less than 0, pass, then print the value of x in the else part, we can straight away write the expression like this: if x is greater than or equal to 0, then print x, otherwise no. Let us run this code, only this code. Let us enter the value of x. For example, here -3 once again. See, we got nothing because the condition is false. Let us run once again and enter +3. So we got the value 3, just the display of the print statement. So if you ever feel the need to write an if else statement with an empty if body, we can do either any one of the works. What I would like to mention here. The first one is invert the truth value of the condition, and in the second, make the proposed else body of as the if body, and in the third case, once you make the proposed else body as the if body, eliminate the else. So in situations where you may be tempted to use an non-functional else block, like if x is equal to 2, then print the value of x, else do nothing. Means print the value of x only if the value of x is equal to 2, and do nothing if x is not equal to 2. So in this case, if at all if we want to print any useful or very important message, we can use the else part. Otherwise this else part has no use. So we can only use this expression or this block of code, if block. If x is equal to 2, then the print the value of x. So in Python, the pass statement is useful for holding the place for code to appear in the future. So in this case, for example, if we consider this small code, if x is less than 0, pause, do nothing and wait for the programmer to enter some code in future. If x is less than 0, if this condition becomes false, just print the value of x. So in this case, the pause statement serves as a suitable placeholder for the future code, and the comment will just report what is expected to appear eventually in place of the pause statement in future. So here we are just writing do nothing, but we can write anything like if x is less than 0, do subtraction operation. So this is the valid instruction in the form of a comment. So in future the programmer has to do some subtraction operation instead of the pause statement. So pause statement serves as a suitable placeholder for the future code, and this is how we can use the pause statement. And how it is very important in Python. So we came to know the importance of pause statement in the control flow statements in Python. Let us move on to the nested if and nested if else conditionals.